In this video, we're going to work on some definite integral problems. So let's jump right into it. Let's start with this example. What is the antiderivative of x to the third, evaluated from 2 to 4? How can we integrate x cubed? Well, let's review some basics. If you want to find the antiderivative of x to the n, it's going to be x to the n plus 1 divided by n plus 1. So the antiderivative of x squared is x cubed divided by 3. The antiderivative of x to the fourth is x to the fifth divided by 5. And for x to the seventh is x to the eighth divided by 8. So therefore, if we wish to find the antiderivative of x cubed, it's going to be x to the fourth divided by 4th, but evaluated from 2 to 4. So we need to plug in the top number first, and then the number on the bottom. So let's plug in 4. It's going to be 4 to the fourth divided by 4 minus 2 to the fourth divided by 4. So what is 4 to the fourth power? Well, for one thing, we can cancel a 4. So this is going to be 4 to the third power. 2 to the fourth is 16. 4 to the third, that's 4 times 4 times 4, that's 64. And 16 divided by 4 is 4. So the final answer for this problem is 60. Here's number 2. Go ahead and find the antiderivative of 7 dx, evaluated from 4 to 10. So what is the antiderivative of a constant? All it is just going to be 5 times x. The derivative of 5x is 5, so the antiderivative of 5 is 5x. Another way you can see it, 5 is the same as 5x to the 0, because anything raised to the 0 power is 1. And so you can add 1 to the exponent and then divide by that number, which will still give you 5x. So the antiderivative of 7 is 7x, evaluated from 4 to 10. So first we're going to plug in 10, and then after that we're going to replace x with 4. 7 times 10 is 70, 7 times 4 is 28, and the difference between these two numbers is 42. So this is the answer. Now what if we have a polynomial function? Let's say 3x squared minus 5x plus 2, evaluated from, let's say, 1 to 2. So you just have to find the antiderivative of each term. The antiderivative of 3x squared is going to be 3x cubed divided by 3. And the antiderivative of negative 5x is negative 5x squared divided by 2. Just add 1 to the exponent and then divide by it. And for a constant, simply attach an x to it. So let's plug in 2 first. So it's going to be 3 times 2 raised to the third power divided by 3 minus 5 times 2 raised to the second power divided by 2 plus 2 times 2. And then minus. Now let's replace x with 1. So it's 3 times 1 to the third divided by 3 minus 5 times 1 squared divided by 2 plus 2 times 1. So 2 to the third power is 8. 2 squared is 4. And 2 times 2 is 4. 1 to the third is 1. And we can cancel these 3, so 3 divided by 3 is 1. So the whole thing is 1. And then 1 squared is 1 times 5 over 2. So that's going to remain 5 over 2 plus 2. Now we can cancel the 3's. 3 divided by 3 is 1, so this will just give us 8. 5 times 4 is 20. 20 divided by 2 is 10. And here we could distribute the negative sign. So it's going to be negative 1 plus 5 over 2 minus 2. 8 minus 10 is negative 2. 4 minus 1 is 3. Negative 2 plus 3 is 1. And we could combine 1 and negative 2, which is negative 1. So what we have is 5 over 2 minus 1. And 1 is the same as 2 over 2. So the final answer is 3 over 2. Try this one. Find the antiderivative of 2x plus 3 squared dx from negative 1 to 3. So what should we do in this problem? The best thing to do is to FOIL 2x plus 3 squared. It's the same as 2x plus 3 times 2x plus 3. So let's go ahead and do that first. 2x times 2x is 4x squared, and 2x times 3 is 6x. And then we also have 3 times 2x, which is another 6x. And finally 3 times 3, which is 9. So now let's combine like terms. So this is equivalent to 4x squared plus 12x plus 9. So now at this point we can find the antiderivative. The antiderivative of 4x squared is 4x cubed divided by 3. And for 12x, it's going to be 12x squared divided by 2. And for the constant 9 is simply 9x. So let's plug in the top number first. So this is going to be 4 times 3 to the third power divided by 3. 12 divided by 2 is 6. So we can just replace it with a 6. Then we have 9 times 3. And now let's plug in negative 1. Now we could cancel a 3. So instead of being 3 to the third, is now 3 squared. 3 squared is 3 times 3, which is 9, times 4 is 36. Here we have 3 squared, which is 9, but times 6, that's 54. And 9 times 3 is 27. Now, negative 1 to the third power is simply negative 1, so this becomes negative 4/3. Negative 1 squared is positive 1 times 6. And then negative 1 times 9 is just negative 9. Now 36 plus 54, that's 90. Next we're going to distribute the negative sign, so it's going to be positive 4 over 3. 6 minus 9 is negative 3. Combined with the negative on the outside, that's going to become plus 3. Now let's add 27 and 3. So that's going to be 30. And 90 plus 30 is 120. So now, to add these two, we need to get common denominators. Let's multiply 120 by 3 over 3. 12 times 3 is 36, so 3 times 120 is 360. So the final answer is 364 divided by 3. So this is it. Let's try this one. Find the antiderivative of 1 divided by x squared, evaluated from 1/2 to 1. Now the first thing that we need to do is we need to rewrite the expression. 1 over x squared is the same as x to the negative 2. And now we can use the power rule. We can add 1 to the exponent. Negative 2 plus 1 is negative 1. And then divide by that result. So now let's rewrite it. If we bring the x variable back to the bottom, the negative exponent will become a positive exponent. So this is negative 1 over x to the positive 1, or simply x, evaluated from 1/2 to 1. So let's plug in the top number 1. So it's going to be negative 1 over 1 minus negative 1 divided by 1/2. Negative 1 over 1 is simply negative 1. And these two negative signs will make it positive. 1 divided by 1/2 is 2. So the final answer is plus 1. By the way, when you divide 1 by, let's say, 1/4, this is the same as multiplying 1 by 4 over 1. Perhaps you heard of the expression keep, change, flip. Another way in which you can simplify this result is if you multiply the top and the bottom by 2. On top, you're going to get 2, and on the bottom, 1/2 times 2 is 1. So the whole thing is simply 2. Now, what about this one? Feel free to try this example. Now, if you decide to rewrite the expression, if you add 1 and then divide by that result, notice that this will be undefined. So this doesn't work. You need to know that the antiderivative of 1 over x is simply ln x. For now, I would commit that to memory. So now let's plug in the values that we have. So first it's going to be ln e minus ln 1. Now you need to know that ln e is always equal to 1, and ln 1 is always equal to 0. So the final answer is simply 1. Now, what is the antiderivative of the square root of x? Go ahead and try this one. Now, the first thing that we should do is rewrite the expression. The square root of x is the same as x to the 1/2. So we can use the power rule. What is 1/2 plus 1? 1/2 plus 1 is basically 1/2 plus 2 over 2, which is 3 over 2. So when we add 1 to the exponent, it's going to be 3 over 2. And then we need to divide by 3 over 2. But dividing by 3 over 2 is the same as multiplying by the reciprocal, which is 2 over 3. So we're going to evaluate this from 4 to 9. So let's plug in 9 first. And now let's plug in 4. Now, what exactly is 9 raised to the 3/2? 9 to the 3/2 is the same as 9 to the 1/2 raised to the 3rd power. 9 to the 1/2 is the square root of 9, which is 3, and 3 to the 3rd power is 27. So that whole expression is just equal to 27. So we have 2 times 27 divided by 3. Now let's do the same thing for 4 raised to the 3/2. So it's 4 to the 1/2 raised to the 3rd power. The square root of 4 is 2, and 2 to the 3rd power is 8. So this is going to be minus 2 times 8 divided by 3. 2 times 27 is 54, and 2 times 8 is 16, and 54 minus 16 is 38. So the final answer is 38 divided by 3. Here's another one for you. What is the antiderivative of x cubed minus 5x squared divided by x from 2 to 3? So if you see a problem like this, what would you do on a test? If you have a fraction and if there's only one term in the fraction, separate it into two smaller fractions. So what we could do is divide x cubed by x, which is x squared, and divide negative 5x squared by x, which is negative 5x. The antiderivative of x squared is x to the third divided by 3. And for 5x, it's going to be 5x squared divided by 2. So now we could plug in the numbers. So it's going to be 3 to the third divided by 3 minus 5 times 3 squared divided by 2 minus 2 to the third divided by 3 minus 5 times 2 squared divided by 2. Three to the third is 27, divided by 3 is 9. 3 squared is 9 times 5, so that's going to be 45 over 2. 2 to the third is 8. 2 squared is 4 times 5 is 20, divided by 2 is 10. So this is what we now have. Now let's go ahead and distribute the negative sign. Now we can add 9 and 10. That's going to be 19. So we have 3 terms with different denominators. To combine them, we need to get common denominators. The common denominator of 1, 2, and 3 is 6. So let's multiply this by 2, this one by 3, and this one by 6. Now what exactly is 19 times 6? 10 times 6 is 60. 9 times 6 is 54. So if you add 60 and 54, that's 114. Now you can also multiply 20 times 6, which is 120, and take away 6 from 120, that will give you 114. Now 3 times 45. 3 times 40 is 120. 3 times 5 is 15. If you add the 2, you get 135. And 8 times 2 is 16. Now 114 minus 135, that's negative 21 over 6. And negative 21 minus 16 is equal to negative 37. So this is the answer, negative 37 divided by 6. Here's another one that we could try. E to the 3x. What is the antiderivative of e to the 3x? The antiderivative of e to the 4x, for example, is simply e to the 4x divided by 4. This only works if it's like x to the first power. If it's x squared, x cubed, or anything like that, it won't work. E to the 3x, or let's say e to the 5x, will be e to the 5x divided by 5. The antiderivative of e to the x is simply just e to the x. So this one is going to be e to the 3x divided by 3. So now let's plug in 1/3. So e to the 3 times 1/3 divided by 3 minus e to the 3 times 0 divided by 3. 3 times 1/3 is 1. So this is e to the 1 divided by 3. E to the 0 is 1. Anything to the 0 power is 1. So this is the answer. E over 3 minus 1 over 3. Which you can write it like this if you want to. As a decimal, this is about 0.5728. Let's try this one. What is the antiderivative of cosine x? The derivative of what function will give you cosine x? The derivative of sine is cosine. So the antiderivative of cosine is sine x. So what we now have is sine pi over 3 minus sine pi over 6. Pi over 3 is like 60 degrees, and sine of 60 is root 3 over 2. Pi over 6 is 30. Sine 30 is 1/2. So the final answer is square root 3 minus 1 divided by 2. And as a decimal, that is equal to 0.366. Let's try another example with a trig function. What is the antiderivative of sine 2x? The antiderivative of sine is negative cosine, because the derivative of negative cosine is positive sine. The derivative of cosine itself is negative sine. So this is going to be cosine 2x, but divided by 2. Let's say if you want to find the antiderivative of cosine 5x. This is going to be sine 5x divided by 5, for example. So now all we need to do is plug in these values. So this is going to be negative cosine times 2 times pi over 4 divided by 2 minus negative cosine 2 times 0 divided by 2. Now 2 times pi over 4 is basically pi divided by 2. And cosine pi over 2 is equal to 0. 2 times 0 is 0, so cosine 0 is 1. So the final answer is 1/2. Now what is the antiderivative of secant squared dx? So the derivative of what function will give you secant squared? The derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. So make sure you know the derivatives of common trig functions. It's going to help you a lot. So now this expression is equivalent to tangent 3 pi over 4 minus tangent pi over 4. 3 pi over 4 is in quadrant 2, and in quadrant 2 tangent is negative. Tan 3 pi over 4 is negative 1, and tan pi over 4 is positive 1. So this is negative 1 minus 1, which is equal to negative 2. So let's try this problem. What can we do to find the antiderivative? Now, one technique that you can use, you can FOIL this expression and then multiply it by x squared and then find the answer that way. But we're going to use something else, something called u substitution. We could confirm the answer using the old technique, but we're going to use a new technique called u substitution. Now, we need to replace the x variables with u variables. But here's a question for you. Should we make u equal to x squared or x cubed plus 5? You want to make u equal to x cubed plus 5 because the derivative of that expression is 3x squared dx. The x squared in this expression will cancel with the x squared on the outside, which is what we want. Now let's solve for dx. Dx is du divided by 3x squared. So what we're going to do now is we're going to replace x cubed plus 5 with u and dx with du over 3x squared. So this is going to be x squared times u raised to the second power and then du divided by 3x squared. Now what we need to do is we need to replace these values, which corresponds to x values, and we need to plug in the corresponding u values here. So let's use this expression. When x is 0, what is u? So let's plug in 0. 0 to the third plus 5 is simply 5. Now when x is 1, what is u? 1 to the third plus 5 is 6. Let's take the constant and move it to the front. So what we have is 1/3 antiderivative 5 to 6 u squared du. So this is going to be 1/3 times u to the third divided by 3, evaluated from 5 to 6. So that's u to the third over 9. So this is going to be 6 to the third divided by 9 minus 5 to the third over 9. 6 to the third power is 216, and 5 to the third power is 125. If we subtract 216 by 125, you should get 91 divided by 9. So that's the answer. Now something else that you can do, if you want to, at this point, once you integrate the function with respect to u, you can replace u with x cubed plus 5. So this would be x cubed plus 5 divided by 9. Once you change it back to the corresponding x variables, you need to replace these numbers with their original numbers. So now it's going to be 0 and 1 again. But if you plug in these values, you should still get the same answer, which is 91 over 9. Now let's do this the old way. Let's FOIL x cubed plus 5 times another x cubed plus 5. So x cubed times x cubed is x to the 6th power. And if we multiply those two, that's going to be 5x cubed plus another 5x cubed. And then finally, 5 times 5 is 25. Now let's combine like terms. So 5 plus 5 is 10. Next, let's distribute the x squared to every term that we have on the inside. So this is going to be x to the 8 plus 10x to the 5th power plus 25x squared. So what is the antiderivative of x to the 8? This is going to be x to the 9 divided by 9. And the next one is going to be 10x to the 6 divided by 6. And the last one, 25x cubed divided by 3. So let's plug in 1 first. So it's going to be 1 over 9 plus 10 over 6 plus 25 over 3. And if we plug in 0, 0 to the 9th is just 0. Everything's going to be 0 when we plug in 0. So we could just ignore the last part. So now we got to simplify this expression. So what is the common multiple of 3, 6, and 9? The common multiple is 18. So 1 over 9, let's multiply by 2 over 2. So it's going to be 2 over 18. 10 over 6, let's multiply by 3 over 3. So it's 30 over 18. And 25 over 3, let's multiply by 6 over 6. That's going to be 150 over 18. 2 plus 30 plus 150 is 182 over 18. And we could divide both numbers by 2. Half of 182 is 91. Half of 18 is 9. So we get this answer again. Let's try another problem. Let's try this one. 4x e to the x squared. Now this time we need to use u substitution. We can't do it any other way. So what should we make u equal to? You want to make u equal to x squared because du is going to be 2x dx. the x variable in this expression can cancel the x variable there. Our goal is to replace all of the x variables with u variables. Now let's solve for dx. dx is du divided by 2x. So then this is going to be 4x e. Let's replace x squared with u. So this is e to the u. And dx is du divided by 2x. Now we need to change the values. When x is 1, u is 1. U is equal to x squared, or 1 squared, which is 1. And when x is 2, u is equal to 4. So our new values are 1 and 4. Four x divided by 2x is 2. So this is 2 antiderivative e to the u. The antiderivative of e to the u is e to the u. So if we evaluate it from 1 to 4, this is going to be 2e to the 4 minus 2e to the first power, or simply 2e. So this is the answer. Try this one. Can we use u substitution on this particular integral? Notice that if we make u equal to x, du is going to be 1 dx. We won't be able to cancel the x that we see here. For this problem, you need to use something called integration by parts. And you need to know the formula. The antiderivative of u dv is equal to uv minus antiderivative v du. Now let's make u equal to x. And the dv part, we're going to make it equal to e to the x dx. So this is the u variable, and this is the dv part. Now we need to find two other variables, du, which is the derivative of x, that's 1 dx, or simply dx, and v. V is the antiderivative of dv. The antiderivative of e to the x is simple, it's just e to the x. So now we just got to use the formula. So u dv, which is x e to the x dx, is equal to uv, which is x times e to the x, minus the antiderivative of v du, which is e to the x dx. On the left side, this is our original problem. So let's focus on the right side. The antiderivative of e to the x is simply e to the x. So the antiderivative of x e to the x is x e to the x minus e to the x. So now we need to evaluate it from 0 to 1. Now let's plug in 1. So this is going to be 1 e to the 1 minus e to the 1. And if we plug in 0, it's 0 e to the 0 minus e to the 0. So 1 times e to the 1 is simply e. And if we subtract that by e, these two cancel. And 0 times e to the 0 is 0. E to the 0 here is 1. So it's negative times negative 1, which is positive 1. So this is the final answer for this problem.